Welcome to MyProjectBazaar.com. Now we discuss about the product for knowledge-based neural network model for FPGA logical architecture development. Next we see the abstract for the product. Field-programmable gate array have been promoted in many applications such as telecommunication, industrial control and data processing and so on. Because FPGA-based electrical systems have high performance and power efficiency, flexibility and reconfigurability. These advanced characteristics have their origins in the unique architecture of FPGA. The typical FPGA is an array of logical blocks and routing resources. The logical block can be configured to realize variation logic function required in practical applications, and the routing resources are configured to interconnect the logical blocks. Given the physical area constraints of the chip, architecture designers need to determine the parameters such as the size of amount of logic and routing resources so that the designed architecture support high system integration and high performance and high resource utilization for overall logical architecture. However, the designing the efficient architecture is very challenging because the designs involves the determination of optical values of several architecture parameters that requires complex trade-offs. This paper proposes a knowledge-based neural network modeling approaches for field-programmable gate array. The logic architecture designs the KPNN embeds the existing FPGA analytical model into the neural network. The neural network can complement analytical models according to their needs, provide the further increased model accuracy while maintaining the meaningful trends successfully captured in the analytical model. The obtained KPNN predicts the routing channel with regard to the circuits implementations of various FPGA architectures, which can be used to architecture to quickly and accurately evaluate the various FPGA architecture in each early development stages. Experimental research showed that the KPNN based approaches achieve to average power and set of benchmark circuits and FPGA architecture. The KPNN model has been applied to 3 FPGA architecture development scenarios to demonstrate its practical application and effectively. Next we see the flow diagram for the product. We develop the different kind of architecture and to run the synthesis report analysis and to note it down all the synthesis output values based on these parameter output values, and to collect all the values and to create any one of the database creations. Each creation we kind each matrix format files, and we implement the 10 circuit implementations for example 1 based on the process, and to select any one of the data files in the data matrix format, and to if on example adder file to be select and adder file to produce the kn f input n f output fs ln by 2 parameter output results, and to collect these kind of parameter and to analyze the feature values for overall architecture. These feature values to update the weighted functions generation and to create the weighted value output, and another one input is the parameter output. These two kind to produce the multiplying output results, and this kind of multiplication operation we use the approximate based multiplier architecture for overall architecture process. Then to identify the hidden neuron generation process. The hidden neuron generation process to identify the minimum neuron values, best neuron values, and to apply the Cordic element based process. The Cordic element based process we update the Gaussian kernel unit functions for the minimum difference between the selected terminals and the test vectors and the selected vector and test vector to identify the overall test vector output results, and to apply to the Cordic based architecture. This Cordic based function used to identify the maximum matching to the selected multicore architectures. This transformation function architecture to passing to the tan sigmoid function. This tan sigmoid to identify the minimum logical block for neuron calculation designs based on the process. Then we update the knowledge based on our weighted knowledge update process. This knowledge output bits to set the any one of the threshold functions value. This threshold function to identify the how many routing wires to implement in the selected architecture. So we analyze this kind of prior knowledge to apply to the system functions. This function to update the mismatched data bit and output channel with calculations. This function to identify the channel with calculation function for every selected routing architecture in FPGA based process. Finally, we see the output for the product. This is our the FPGA neural network based process. We implement the matrix file for overall data sets. Each matrix file to represents the parameter value based on the 6 parameter value for each and every core architectures. Example, adder, comparator, multiplier, divider, any other things. So we run the main function for overall architecture process. You just run the file. Just open the dataset and to select any one of the matrix files. Each matrix file considers the any one of the architecture functions. Then to open the FPGA based KPNN neural network architecture based process. This process to analyze the feature values based on the DFT architecture and to identify the neural network function based on the knowledge based work architectures. The knowledge based work architecture to represents this kind of parameter and to analyze all the values, and to finally we calculate the how many routing wire and routing width to required in our architectures. Example kind of functions to be represented in our overall architecture based process. Then to select the simulation function to select and finally run the simulate behavior model. This model to represents the architecture based work and to set the values for all our functions, and to set the how many routing wire to represents our architecture. We just select the clocking signal and to apply the leading edge 0 and trailing edge 1 and the clock period for 1000 nanoseconds, and just to run one time and to analyze how many count to be presented in our architecture, and we select the 16th model. So 16th model to be identify the minimum threshold value for our overall required architecture. These are the final simulation output for required functionality for required output data bits. So we consider the channel width is 27 for required our 16th architecture functions for our required output data bits. These are the final simulation output for overall architecture based process. Then we select some other things. We identify the routing values to be different. If we select the second data signals and to produce the output data bits for each and every architecture parameter kinds some kind of things. So we select the second model and to produce the same functionality for overall architecture. So the channel width consider only 4. This knowledge to update the neural network based knowledge network for our overall architecture process. These are the final output for the knowledge based neural network architecture based on the FPGA kit implementation process.